Okay, let's see. Okay, we denote x1 equal to y just now, right? And then we know that we want a 2 by 2 matrix. So how does it look like? So we have x1 dot and x2 dot, right? Okay, we are going to make it into this state equation form. Okay, x dot plus ax plus bu. Okay, so means that you have a over here, and then you have x1, x2, right? Okay, so we denote here, we start with x1 equal to y, and then x2 equal to y dot, example. Okay, and then from there, okay, because we want to get x dot and x2 dot, x dot and x2 dot, so we are going to derive x1. Okay, so we make it into state x1 dot equivalent to y dot, right? And x2 dot equal to y double dot. And you actually can see that y dot here is actually same, right, as x2, right? This one. It's the same, Okay, this is how we define. So sometimes you guys are going to define differently. For example, you don't use x1, x2, you use z1, z2. Okay, it doesn't matter. It's how you define it. Okay, so so I can just put it here. Okay, equal to x2, right? So from these two variables, okay, try to match with what we have over here. So x1 dot, do we have x1 dot here with x2 variable? Yes, you already have the answer, right? So meaning what? Meaning this one is a complete equation already. But how about this? x2 dot, is it a complete equation yet? No, right? So you need to solve for this y double dot. Okay, so if we just put in the parameter that we have, x1 dot equal to x2, so we have 0 and 1. Do we have any input? No, right? 0, input u. Okay. So we need to continue to solve for y solve for y double dot lah. Solve for y double dot, meaning that we are going to use this equation to solve it. Okay, so we have 5y double dot plus 7y dot plus 4y equal to, okay, let's say we define u1 equal to ft, okay, 4y plus u1. Okay, so f y double dot is x2 dot plus 7, y dot is x2 plus 4y 4xy equal to u1. Can you do you get the meaning, the process from here to here? Okay, substitute y dot with x2 dot, substitute y dot with x2, because you want to use the variable that we have here, x1 x2 or x1 dot x2 dot. Okay, you don't want to use y anymore, y or y dot. Okay, and then y here we change it with x1. Okay, and then you define just now ft equal to u1. u1 will be the input. Okay, so after you have this, then you can see that, oh, Now you have x2 dot, the one that you want to solve over here, right? x2 dot. Okay, so x2 dot equivalent to 1 over 5 u1 minus 4 over 5 x1. Okay, I'm going to rearrange it according to x1, x2. Okay, and then minus 7 over 5 x2. Okay, so based on this, you already completed for x2, which is over here. So put it into the state equation. Okay, this is the state equation. So you have x2 dot equivalent to, input tadi kan, 1 over 5 u1, right? So 1 over 5 u1, so 1 over 5. Okay, x1 you have minus 4 over 5. So x1 is minus 4 over 5. x2 is minus 7 over 5. Minus 7 over 5. Okay, so this will be the state equation. How about the output equation? There's no output equation lah. You were only given this second order system kan? So there is no output equation. So output equation, so if you, just for the sake of writing it out, y out, y equal to 0. Okay, you can just write it as x1, x2 plus 0. Okay, remember this example, you are not even given a free body diagram kan? You were given a equation. Okay, so from equation you can come up with the state variable based on your understanding on the system. Okay, so you need to know when you look at system like this, especially when you think about a system of mechanical system lah, y double dot, y1, y dot and y. Okay, it means that, oh, the original equation, the input will be x lah, the displacement example. Okay, even though it doesn't say that what type of system, is it a electrical system or mechanical system. But to make your life easier, to understand how to derive it, then you think about a mechanical system much more easier. Okay, any question? Kau lah tak dapat, kau tak dapat yang ni, parah ke lah.
Yang ni untuk soalan exam dia bagi bentuk macam ni lah.
Tak, soalan exam dia bagi bentuk macam ni. Bentuk yang macam tadi, gempa bumi tadi.
Tapi waktu dia dah bagi dalam bentuk.
Tak, dalam soalan exam, you will be given a system. Contoh yang bangunan tadi 3 tingkat. Even I don't actually give you M1, M2, M3 mass tu, you kena define sendiri based on your understanding. Okay, sebab the correct answer will be 3 mass lah. Kalau you jawab 2, salah lah. So from that 3 mass, you come up with the modeling kan, the block diagram lah. The block diagram, dulu modeling simplified block diagram tu, and then come up with the equation. So you will actually get this type of equation lah from the modeling. From that equation, then baru you buat state variable. Okay, tak apa. Kita tak habis lagi, ada banyak lagi sebenarnya. Okay. So, we are going to look at, we take one system like this. I'm not sure if it's in the notes. Ada tak dalam notes? Ada? Okay. Notes tu memang ada. Okay, contoh yang ni. I'm going to give you right from zero lah basically. So, let's say that we have a mass spring damper model given the following form. If you notice okay, so if you look at control theory, most of the time, the unit is systems kan. Why do we always get this function? What does it mean by this function? Then you want to get what is the response kan? So it doesn't make sense sometimes when you don't look at the physical system. For some people lah. For myself, I need to look at the physical system, then only understand, oh okay, comprise of mass from damper. Okay? So let's say that okay, you have a mass from damper system. Is this mass from damper system? No, right? Dia tak cukup apa? Damper. There's a damper inside kan? Okay, so scratch that. We design our own diagram Okay, so let's look at a mass spring damper system. Mana? Satu example ada satu kunci yang ada macam spring juga. Next ni. Okay, let's see ya. Dia nak letak mana ni? Okay lah, example. Yang ini, the end of this spring is connected to this one fix. Fix Fix. So I'm going to off. What happened? It will go back to the original position, right? So what you have here is what? Mass. This is mass. We have spring. Okay, and then we have damper. Well, how about friction? We have friction, right? Friction is considered as damper. It's considered as damper also, right? Let's say that we take a real life punya example lah. Okay, we don't omit that friction. Kalau tak ada frictionless maksudnya dia gerak rosak kan? So tak ada friction kan? So bila kita tarik dia akan gerak. Ni tak berapa cepat lah sebenarnya kan sebab dia a bit ni kan, flexible kan. So supposedly it goes back to the original position. So tarik, same. Okay. So let's say we model that. Okay. So example. Okay. We have a system just now whereby you have a spring, mass, and then you have the fix, the ground, okay? So you have K and then you have B. B is the friction. This friction lah. Any friction here. Okay. And then what happened just now was that he gave the input. He bagi input, assuming that tangan anda ni actuator ni tolak kan? Kita masuk balik tolak. So this one is input to the mass here system, and then you also have what? Displacement, right? This mass is moving in x direction. Okay, so what we're doing is actually modeling the system just now lah. Daripada nampak physically, then we model it. So this is B. B is friction, okay, and then so we have the force U, or we have the force there, and then we have the displacement. Okay, so based on this, what is the first step if you want to get the transfer function? You do the free body diagram, right? So you do M. Try to do that. Get the equation. You should be able to get one equation. So you have mass here, you have force, right? So you have here mx double dot, betul? Then you have bx dot, then you have kx. Okay, so you have the free body diagram. So you now can actually come up with the equation. Okay, equation. So the equation is mx double dot plus bx dot plus kx equal to f or u, equal to u. Okay, let's say we denote, okay, we define. The question is that define input as u, t, output as xt. Okay, so follower dah siap. Ni boleh faham kan? Simple je. Kalau imagine kalau ni ada lagi satu mask kat sini connected dengan M ni, atau parallel ada 3 kan, macam mana nak denote? Sama je, kena buat 3 lah free body diagram Okay, so most of the time, okay, in a question, good question by the student lah, mana tadi yang ni kan, equation ni dibagi macam ni ke? Tak lah, dia daripada ni tadi, daripada ni equation ni kan, you derive it from a system actually. Okay, so in NICE punya control book semua kan, even in undergraduate, you see that the lecturer give all the equation kan. Dapat dari mana equation ni kan? Equation tu sebenarnya dapat daripada modeling system lah, tapi tak buat lah modeling tu kan. Right, so most of the time after you come up with the free body diagram, you come up with the equation, first order equation like this, okay, second order equation. Then what you do is that you use Laplace, okay, transform betul? You use Laplace transform, then you can write it as m apa? S squared xs campur bs xs plus kxs equivalent to u s. Okay, then what you want to do is that, okay, let's say that, okay, you define just now ni kan, input dan output kan. So if you define input output like that, I would suggest every time if it's define input and output, then draw a block diagram. Input, output. Input is what? Xt. Output, u, t. Alright? So normally you want to get gs lah, the transfer function kan. So gs. So gs is equivalent to terbalik. Tak nampak terbalik Selalu x kan input kan, tapi dalam sistem ni kita denote input adalah u So input u, us, output x, s. Okay, so gs will be what? Apa equation dia? Tak payah hafal lah. Kalau tak hafal, jangan hafal lah. I pun tak hafal juga. I malah nak fikir kan. Selalu I buat macam mana? XS output equal to G times QS. Betul? XS equal to what? G times US. Therefore, GS equivalent to XS over US. Walaupun dah ni, I macam selalu lupa. Output bagi input ke, input bagi output. Dah lah, lukis je lah. Transfer function. Bila you lukis, when you draw out, you understand. You understand, oh okay, this is the output, the correct output. Okay, so output over input lah. Okay, so what you want to, why we actually move to this direction just now is because we want to find the, what was the aim of this We want to find the transfer function kan? The transfer function of the system. Okay, in Laplace, in S domain lah. Okay, so right now, do we have access in this equation? Do we have? Yes kan? Ni. Do we have US? Yes. Then we can get the transfer function. So, how we do that? We take out XS, okay, and S squared plus BS plus K, right, equivalent to US. Then we can already write out the transfer function. So, just now transfer function is GS X over U kan? So, by X, yeah. So, GS equivalent to XS over US. So, you have 1 over M squared plus BS plus K. Then you get the transfer function. This is the transfer function of the system in Laplace. Okay, in frequency domain lah. Okay, Laplace is in frequency domain. Okay, so why I'm talking about this equation actually? Okay, actually why I'm talking about this equation is that you want to convert it to, the question was this one kan? Consider the second, this one the general mass spring damper model is given in the form, but in this form just now. So basically what we derived just now lah. Okay, I'm using a system whereby we have all of the element. Okay, so actually how we can add on to this drawing is this one. Tambah lagi satu. You can either add here K and C, or just now as the friction damper. Okay, so we want to convert the equation into state variable model. Okay, so we start off with defining the variables. Okay, so define the state variables. Okay, so let's say that, okay, let's say we have x1 equal to x. How we can go by this is that look at the input that we have. Only one, right? X. So when we have x, then like I said just now, we can denote it as x dot, and then we also can get x double dot. Alright, so we want to have x as the input variable. Input variable just now, what was the equation? The equation was x dot mana dah keluar ni, is x equal to a, x plus bu, y equal to c, x plus d u. Okay, so we are looking at x here. X is this point. We only have one, right? So x. Okay, so then therefore we can actually denote x as x1. x1, we want to take out x1 as x and x2 x dot. Okay, so from this, we can get x1 dot equal to x dot, right? Which is equivalent to x2. Mana? Yang ni kan? X dot is x dot here. Okay, so let me use a different color. This one sama. Okay, so it's equal to x2. So you find that the equation for equation 1 is complete already. Oh, I got one equation already. Okay, now we move on to x1. We want to get what is x2 dot. Okay, x2 dot is x double dot So x double dot, we don't have that answer inside here yet. So similarly to what we have done in the previous example, it's almost similar actually, but this one is we derive from the model, from the mechanical model. So what you want to do is that we are going to look at the first transfer function that you derived just now, this one, the transfer function that you derive, whereby is this equation. Okay, meaning that the step to get the state variable is you need to get the equation, okay, in the first order equation like this. Okay, then only you can proceed to do the state variable. For this case is that either this one or this one lah, but I will use the one that before Laplace transform, so using mx double dot there. So based on this equation, so we have mx double dot plus bx dot plus kx equal to u. Okay, don't forget we need also to define the input. Lupa nak define input is what? u1 equal to u, right? Okay, so based on that, we now can actually express this equation in terms of the new state variable. Okay, so express using the state variable. So you have mx double dot is what? x2 dot plus b x dot is x2, x dot is here and here. Okay, is x1 dot, but we already get the answer for x1 dot, so x2 plus kx, x is x1 equal to u is u1, the one that we find here. Alright, so from here, now we can write out the state equation. The state equation is this one, just now. Mana nak angkat ni? Okay, based on state equation, so we can write here, okay, so x1 dot, x2 dot, okay, write out first what is the variable x1 and x2 plus, okay, so x1 dot we have equal to x2, so you have 0 and 1. Do you have any input? No. So have u, the 0, u, x2 dot, is this equation, right? So we haven't finished doing it yet. X2 dot equivalent to U 1 over M U tadi U minus M K minus K over M x1 minus B over M x2. So you have x2 dot equivalent to x1 is minus K over M, x2 is minus B over M, U is 1 over M. Okay. Okay, this is the input. Okay, we also need to define also output, right? Output, what's the output? Equal to X, right? Output is X. So output is equivalent to X, which is equivalent to X1. Okay, so this one is the important parameter. Okay, so the output equation also can be defined as y equivalent to, we have x1, x2, sorry I punya handwriting memang macam ni lah sebenarnya, even on paper pun macam ni, so memang tak boleh diubah lagi lah. Okay, so I'm really sorry. Okay, ini pun dah cukup cantik lah ni bagi saya sebab ada lagi teruk. Okay, so x1 and x2 plus, okay, so y, the input just now is, output ni I kena define as y lah, y equivalent to x kan, you define in here, and equal to x1 so y is x1. So you have 1 and 0 plus 0. Okay, you don't have any input to the to this equation tak ada. Okay, so basically, okay, we were talking about, is there any relationship between output with the input just now, right? Even though in this block diagram it says that it's directly connected, right? But after we derive, we find out that no, based on our state variable, actually your output is only linked with the input just now. Okay, output is only linked with the state variable x1 only. Okay, so this is one example of how you can solve an equation lah. Okay, ini apa? Okay, so this one you can try this at home. This one is given directly, a mass spin damper with this following x2 dot. So come up with the equation. Okay. So how do we go about this equation? For example, any question? Tak ada. Belakang okay? Belakang okay. Okay, this example, we have a two mass system. Example of maybe quarter cast suspension system, okay, maybe. So, but it directly give you the equation. Example, you have done it in the part 2, before this. Try derive it on your own. And then you get this equation, x1 dot, x2 dot, x3 dot, x4 dot. So how do you come up with the state representation? Okay. So I think this is kind of easy because it's already given to you. So you can actually do that by separating out, okay, according to the input variable. Okay, so you have A in this term, B you have this value, and X you define it X this value. Okay, so try to do it at home and then express it in the state variable form. Okay, this one is a solution. Okay, next slide. Okay, let's look at this example whereby you have a mass spring damper is an upgrade of this one. Okay, upgrade of this one. It become this one. Okay, is it the same? Almost the same lah. Almost the same. Okay, so what you need to do is that you need to start with the free body diagram first. Okay, free body diagram. Let's come up with this. Okay, so let's do there's a step in the solution. So draw the free body diagram and ada kelas ke depan ni? Ada kelas? Berapa kelas? Kalau extend lagi tak apa? Extend sikit supaya tak perlu buat kelas. Okay, tengok macam mana. Okay, so state variable. Okay, first is that like always what we did just now for one mass system. Okay, you need to come up with the free body diagram. Okay, and derive the equation of the system. Okay, assuming here that is a frictionless, so tak ada T lah, B tak ada. You cuma ada K sana dengan D sana. D is B lah, basically. Okay, then define the state variable. Then rewrite the equation that you derive in number 1 to the new state variable and solve for the highest derivative. Find the upper equation using transfer function and write in the matrix form for state and output equation. So let's do this. Draw the first one first. I give you 1 minute to draw the free body diagram. Okay, first, please. 1 minute. You ada slot free hari apa minggu ni? Ada slot free tak? Jumaat saya tak free. Oh, okay. Tak apa. Saya pun tak free. Hari lain? Khamis pagi tak boleh. Kalau saya buat online, dah lah. Online ni macam-macam nanti. Macam-macam masalah. Masalah satu, sudah tak dengar saya. Lepas tu, faham ke tak pun tak tahu juga. Kalau kelas malam? Minggu ni je sebab minggu depan dah cuti kan? Kelas malam? Sebelum hari UU exam lah kan? UU exam hari Jumaat kan? Hari Rabu. Hari ni apa? Selasa kan? Kalau waktu rehat, ada waktu rehat tu ada gap yang macam panjang tak? Bukan 1 jam je lah. Bukan 1 hingga 2. Rabu petang free. Rabu petang ni. Sekejap. Rabu petang boleh lah kot. Rabu petang free. Saya so far macam free. Rabu petang lah. Senang sikit. Maknanya BK sini ada kosong kan? Petang kan? Rabu petang tak ada apa kan? So nanti I booking lah. Mungkin BK petang booking ni pun boleh juga kan? BK kecil sikit lah. Besar-besar pun tak best juga mengajar kan? So BK yang ni pun tak apa. Rabu petang lah. Confirm by the way, tak ada bagi tahu pada admin ke yang pasal class clash tu?
Kami ini pun macam tu. Kami dah ambil research method dulu. Saya dengan Wani.
Oh, you dah ambil?
Dan memang dia akan clash.
Lepas tu dia step back student masuk kelas mana?
Kalau
sebab kelas yang ni pun team teaching dengan lecturer lain kan, separuh-separuh. So kalau you guys dah tak masuk kelas yang ni, so waktu tu ada exam lagi, macam pelik lah kan. Anyway, macam pelik jugalah macam mana dia buat kelas research methodology tu clash dengan kelas. Tak apalah. Okay, so tapi kena complain lah juga. Dia tak boleh seorang-seorang, tak boleh senyap je. Sebab I think bila you guys senyap, macam tak ada apa-apa. Tapi sebenarnya one of the lecturer yang kena beralah. Menyebabkan payah lah kan kelas tu.
dengan penyelaras
Lepas tu dia cakap apa?
Cakap susah untuk langgar jadual PPS. Maksudnya kami kena follow yang PPS ini.
Oh, itu PPS punya. Itu bawa PPS. Apa dia tak buat je hari Sabtu Ahad?
Sabtu Ahad dia tak buat. Tapi
face to face ke online?
Dia depends on lecturer. Lecturer tu juga.
Kalau dah ada buat hari Sabtu Ahad, okeylah kumpul ramai-ramai je buat Sabtu Ahad. Kenapa nak buat? I mean, weird lah juga pendapat I kan, macam anyway, tak apalah. Okay dah siap dah? Rabu petang kita kelas Rabu petang. Sebab tak siap ni baru mechanical tau. Electrical pun tak masuk lagi. Nak cepat-cepat pun macam boleh orang baca sendiri. Tak tahu nak jawab ke tak tu, exam nanti boleh jawab ke tak. Itu masalah terbesar I lah. So I boleh bagi tapi I you pun faham lah kan, you buat online pun gitulah. Okay, better face to face. Okay dah. Mana seorang lagi? Keluar sekejap. Lecturer lain mengajar macam mana kalau yang ada equation whiteboard? Whiteboard. I dah tak boleh guna whiteboard, tak muat. Kalau buat lepas tu nak kena padam, lepas tu yalah, guna ni je lah. Mana kawan kamu? Dia pergi mana? Toilet? Okay, kita let's say that we define first the variable. We have input. What is the input? X1 and X2 kan? And then we have our output. Apa pula terbalik? Dia easily confused because of normally we use input X. Okay, so we have output X1, X2. Input is F lah. Or for this case is that we use U ataupun F. Nanti ingat O pula. U or F. Okay. So based on that, okay, you can now imagine kan. Oh, you have input X1, output X1 and X2, right? So actually from here you can get what? X1 dot, right? And then you akan dapat X double dot. Same goes to here lah. X2 dot, X2 double dot. Meaning that you will have what type of matrix that you are going to have? Is it 3 by 3? Or is it 2 by 2? Or 4 by 4? Two by two. Ini ada dua output Tadi kita ada satu je output X. So it become 2 by 2, right? Now you have two input. So dia akan jadi 4 by 4 lah. Okay, so actually what we have here is that we define the state variable already here lah. Kita dah define kat sini state variable Okay. So looking at this one, we know that when we have X1, X2, you can actually get the velocity and also we can get the velocity of X2. Okay, so based on that, we want to first come up with the free body diagram. So let's do M2 first over here because we have the input F here. Okay, so we have U, right? Imagine that. Normally when you do this, you need to imagine that you pull it and then it's going to be this force. But imagine that because this mass and K will be in the opposite direction, right? Okay, it's resisting because you know that we have F equal to MA. So you will have M2 X2 double dot. Correct? And then we have K X2. Okay, what else do we have? We have this K connected to mass M1. Okay, so this one will be the opposite direction here. So we have kx1. Okay, this will be the free body diagram for M2. For M1, okay, M1 here, is there any force? No, right? So force is 0. Okay, so we write out the equation M1 x1 double dot. Okay, and then we have B, right? I write it as B lah, yeah? B. So x1 dot, then we have K connected to M1. So Kx1. What else? We have K also connected to M2, which has a displacement of x2. So you have here Kx2. Okay. So now you can, after draw the free body diagram, then you can come up with the differential equation. So write out the equation for M1. So M1, M1 x1 double dot plus Bx1 dot plus Kx1 equal to Kx2. Okay. Let's say I don't want to, in this equation, I want to make it on the left side, yeah, because the force is 0, kan? So minus Kx2 equal to 0. First equation. Second equation, M2x2 double dot plus K x2 minus K x1 equal to U. Second equation. Okay, so you have answered the first part. Draw the free body diagram and what is this? Derive mana tulisan sendiri pun tak boleh baca. And derive the differential equation of the system. Okay, so you already derive it out. Okay, so the second one is that define the new state variable. Okay, define the new state variable. Okay, so since we already have it here, you already define it up here. Okay, we know that later, okay, you will have x1. You will have an equation whereby you have a matrix, kan? And then you have what is the input that you derive? The input variable is x1, x2, right? x1, x2, kan? So we cannot come up with it yet. So let's say that we have, we denote it, even though in the previous example we denote x equal to y and so on. Let's say that I denote it now for this example is z1. z1 equal to x1. So z1 dot equivalent to x1 dot sorry bukan ni, z2. Define a variable x1 dot z3 x2 z4 x2 dot. Okay, so we try to define it like that. Okay, of course, sometimes how you define and how I define is different. Maksud dia apa? Maksud dia, okay, some people might define it as this, okay, dia nak define Z1 equal to X1, and then Z2 dia nak define as X2. Okay, and then baru dia pergi Z1 equal to X1 dot, Z3, Z4 equal to X2 dot. So sometimes your answer and your friend answer is not different. It is not the same. Due to the fact that how you define it, because state variable is up to us to define it. Okay, so let's say that there will be multiple answer lah, but for the sake of this example, we stick to this one. Okay, we stick to this one, how we define it. So based on this, okay, now we can only see the format. Okay, so we have Z1 until Z4, right? So we have the input Z1, Z2, Z3, Z4, right? So you have here Z1 dot, Z2 dot, Z3 dot, Z4 dot, okay, plus B and plus U lah. Okay, B will not be that large, it will be, so basically this one will be a 4 by 4 matrix, this one will be 4 by 1 matrix. Okay, so let's continue. We haven't finished defining it, so we continue from here. Z1 dot equal to X1 dot, right? X1 dot, do you see anywhere here X1 dot? X1 dot is this one, right? So you can directly write it out, Z1 dot equal to Z2. So you have the third equation. Okay, continue, Z2 dot equal to X1 double dot. Do you have this answer yet? No, right? So you need to solve for this. Z3 dot equal to X2 dot. X2 dot, do you have X2 dot anywhere here? Yes, you have. You have Z4, so equal to Z4. So you have the fourth equation. Okay. So last one is Z4 dot equal to X2 double dot, whereby you don't have it yet. So it means that you need to solve for Z2 dot and Z4 dot. Okay, this one. Okay, so number 2 is finished. Define the new state variable. Now we go to number 3, rewrite the equation using the new state variable, means the equation 1 and 2 using this new state variable. Ini dah senang lah. Cuba buat, gantikan. Cepat. Gantikan. Equation 1 and 2 with the new state variable. Okay. So, gantikan. Kalau saya nulis je kan. You buat pula. Okay. After you substitute it, make sure you take it, you leave it with Z2 dot and Z4 dot. Keluarkan terus. Get the equation. Okay. Number 3. Okay. Number 3 what? Substitute. Substitute equation 1 and 2 with 3 and 4 to solve for the state equation. So Z1 dot, the order is Z2 dot, Z2 okay. Z2 dot, where can you get this? Is based on Z2 dot is x1 double dot, right? So it will be based on the first equation. Okay, try to get that equation. Cari Z2 dot and Z4 dot. Okay, continue. Z2 dot, what do you get? This one kan? Substitute into equation 1, right? So you have, let's say that m1 x double dot is z2 dot plus bx1 dot is z2 plus kx1 is z1 plus kx2 is z2 equal to 0, right? So rearrange, since we want to get z2, so you have z2 dot z2 dot equal to salah ke? Mana? KZ1 x1 z1 tolak kx2 salah ke? KZ aduh, okay. Itulah dia. Lain kali jangan letak sini. Okay, sekejap. Padam dulu. Confused. Okay, sorry. My bad. Okay. sendiri confused lain kali jangan buat macam tu Okay. So ni salah ni salah lah ni. Kejap. Ni salah. Okay. So B x1 dot is z2 plus kx1 is z1 minus kx2 z3. Okay. Right. So rearrange it, you will get ada kelas ke depan ni? Let's see. Tak ada. Okay, z2 dot, you will get what? Rearrange it again lah kan. So minus k over m1 z1 minus b over m1 z2 plus k over m1 z3. Right? Everybody got the answer? So what you have it, you get another equation which is z2 dot lah. So this is z1, this is z2. Then just for the sake of rearrange it, we write down what is z3. Z3 you get z4, right? Equal to z4. Okay, this is done. Z4 dot. Okay, you need to use the second equation. Okay, second equation. This one. So you will have m2 x2 dot is z4 dot plus k x2 is x3 minus k x1 is z1 equal to u. Okay, so rearrange that equation, okay, to get z4. Then you have z4 dot equal to u over m2 plus k over m2 z1 minus k over m2 z3. Okay, so now you have completed all the state variable z3a. Kenapa dia keluar macam ni? Z3 and Z4. Okay, so you have completed writing the equation for the state variable. Okay, we write again number 3 done. Okay, okay, find the output equation. We can skip that. You can just derive it on your own based on the equation here. Okay, dapatkan transfer function lah basically. Transfer function find that. I'm going to directly down there, write in the matrix form for the state and output equation. So number 5, number 4, okay, derive the transfer function, okay, based on equation 1 and 2. This is do it on your own, DIY. Okay. Number 5 is state equation. Okay, right, in terms of state equation. So state equation is whereby you have z1 dot, z2 dot, z3 dot, z4 dot. Okay, then you have z1, z2, z3, z4 plus u. Okay, so z equation is based on the one that you find just now. this one. Okay. So key in Z1 dot equal to Z2. So we have 0, 1, 0, 0. Any input? No, 0. Z2 dot equal to minus K over M1. So minus K over M1. Then you have Z2 minus B over M1. K3 is Z3. You have K over M1. Z4 0. No input. Okay, Z3 dot is equal to Z4. Okay, so 0, 0, 0, 1. No input. Z4 dot equal to U over M2. So you have input here. So 1 over M2. Z1 you have K over M2. You don't have Z2. Z3 minus K over M2 and no Z4. Okay. Check if it is correct or not eh. Okay, kejap saya nak ambil ni. Okay, this is only state equation we haven't complete yet. We have another one which is output equation in state space form So output equation Y, what is your output? Tadi kan? Mana tadi output you? Output X1 and X2 kan? Okay, did we define it just now? Kita tak habis define output. So output kenapa salah ke? Saya buat salah ke apa? Betul. Kalau salah bagi tahu sebab kan ialah biasalah manusia kan. Bila dah banyak sangat tu dia ramah mata kan. Okay, so output, jangan lupa output kita tak define lagi tadi. Okay, we define up here, but we didn't define it in terms of here So we know that we have output X1 and X2 So you can have Y1. Okay, Y1 sekejap output. Oh, dia okay. According to the question, you need to read the question first Okay, the question is specific. Even though you have in the modeling, okay, you have displacement X1, X2 but the question here there is that where represent the system translation mechanism system in state space where X1 is the output. X1 is the output that you want to measure lah. Okay, get the equation. So, based on that, unless in this question they had mentioned, okay, whereby there are two output, X1 and X2. But for this case is that they specifically ask that the output is only X1 So, meaning that how we define here is, this is output for it when we do the free body diagram So, you have only Y, output only 1. Okay, there's no Y1 So, only one output, Y equal to X1. X1 is equal to Z1. Okay, so now we can do the state variable, okay, for output equation. So you have Z1, Z2, Z3, Z4 plus 0, U, 0. So Y just now was equal to Z1, right? So you have 1 0 0 0. Okay. So from here, actually what you learn is that, okay, kalau you tengok what we can see this definition of the state equation and output equation. So what you see here is that you have the matrix A. We have A here. We have B, C, and D. Okay. So basically A is, if you look at the definition, is that the system matrix. And then you see that all the system matrix is that it gives you the value based on the system itself. You have all the property of the mass, speed, and then put inside. Okay, and directly you can see that, oh, based on the state x2 dot, oh, this state is affected by z1, z2, and z3 directly. So it's actually a representative of the system directly. So state space is, when you have input and output, it's much more easier to actually analyze. Okay, if you understand the concept of state space. Okay, and then B will be the input matrix. So you can directly see that, oh, Z4 dot is actually where you define the x2 directly affected by the input. And then output is only represented by the Z1, which is X. Okay, so this is an example of how you have a system whereby for this case is that you were given the system, okay, mass, ada dua mass, spring and damper semua, and then you need to, the equation means that the end solution for this is that you need to come up with the state equation and output equation. So first process will be free body diagram as a summary, and then get the differential equation. After that, you don't need to actually translate it into Laplace. Why? Because the objective is that to come up with a state space variable. Okay, unless the question asks you to come up with the transformation, then you need to convert it to Laplace first, then come up with the output of the input to get transformation. So you proceed with define a variable. So defining variable can be multiple solution on how we derive. For example, just now I give you another example, kan, whereby you derive it differently. Or you want to use different. For example, you don't want to use Z1, you want to use Y1. Pun boleh. Okay, up to you. Okay. So you define here, and then you get all of the first differential for this input. Okay, and then you state which one is already have the answer. So you have Z1 dot equal to this 2, and then only 2 equation that is need to be solved based on the equation that you derive from the free body diagram. Okay, after you solve it, you substitute. After you substitute it, okay, then you can get all the variables, and then you substitute into the state equation and output equation. Right? So, any question? No question? Ada lagi ya? Ini next. Tapi ni take home buat kat rumah lah ya. Okay, buat kat rumah. Okay, this one. Example. Okay, this is a rotary system. So you have done this in the part 2 kan? So same concept lah sebenarnya. Come up with the state variable whereby theta 3 is the output. Okay. On Wednesday we will continue. We will continue on how to actually convert the state equation, okay, to transfer function. Okay, just now if you saw the end solution for our derivation is that we come out with the matrix ABCD. Okay. So we can actually come up with the equation, but from this space representation, using A, B, C, and D. So we can do that. Okay, later I'm going to continue with that, and then from transfer function, and also from transfer function to state space. Okay, so transfer function to state space, we are going to use this equation. Okay. So if we look at I already uploaded a new notes with the tutorial just now in ULearn. So you go to under the books and resources. So you can go through example. Later we will go through this example from transfer function to state equation. So I'm going to use the example that we did on the one mass system. Okay, and then we will go to another example on a circuit, one loop circuit. Okay, and then this one is, both of this is a 2x2 matrix. This one, after we derive, of course it's 2x2 because we have a mass there again. So dia akan dapat mx double dot, right? Okay, so we have a 2x2, this one also 2x2. What if, after you derive, you get a 3x3, just like this, right? Just now you got a 3x3, right? 3x3. So how do you actually find transfer function? So this one is a bit long. So nanti on Wednesday we will continue on that. And then a few exercises that you can do it on your own. Okay. And also you can verify using MATLAB lah. Later I will share to you. Okay. So I think that will be all for today. We will continue on Wednesday.